What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Reliable network connectivity. This is critical for maintaining smooth business operations, and cabling issues, they could be a major cause of network failures. So whether you are dealing with incorrect cables, signal degradation, improper termination, or hardware mismatches, understanding how to troubleshoot these problems is essential for any network professional. And in this video, which is aligned with the CompTIA Network Plus exam objective 5.2, we're going to cover common cabling and physical interface issues, their causes, and solutions. All right, so let's begin with cabling issues, and we're going to talk about incorrect cable types first. So using the wrong cable type, this can cause performance issues, connectivity issues, and slow data transmission. And here are some common mismatches. So let's talk about single mode and multi-mode fiber optics. So we have single mode fiber. So this uses a small core around 9 microns and a single light path. And this is designed for long distance transmissions up to 100 kilometers. And then you have multi-mode fiber. This has a larger core of 50 to 62.5 microns and multiple light paths, making it suitable for shorter distances up to 550 meters for gigabit Ethernet. And when it comes to troubleshooting, you want to verify that both ends of the link use the same fiber type. You want to check the color coding of the fiber cables. You have yellow for single mode fiber and orange or aqua for multi-mode fiber. And you want to ensure the correct transceiver is used for the fiber type. All right, next we have category 5, 6, 7, and 8 cable differences. So Cat5, this supports up to 100 megabits per second, and this is considered outdated. You have Cat5e, this is the enhanced version of Cat5 and supports 1 gigabit per second. Cat6, this supports 1 gigabit per second at 100 meters and 10 gigabits per second at 55 meters. You got Cat6a, this supports 10 gigabits per second at 100 meters. Cat7 and 7a, they use shielding for better performance, and they support 10 gigabits per second. Then you got Cat8, this supports up to 40 gigabits per second over 30 meters. Now, when it comes to troubleshooting, you want to ensure the cable category matches network speed requirements. You want to replace outdated Cat5 cables in high-speed networks. You want to verify connectors and patch panels are rated for the same category. Next, we have shielded twisted pair and unshielded twisted pair. So shielded twisted pair, this has extra shielding to protect against electromagnetic interference. An unshielded twisted pair, this is more common and cost effective, but it lacks the EMI protection. And when it comes to troubleshooting, you want to use STP in high interference environments, whether near electrical cables, radio towers, or industrial settings. And you also want to ensure proper grounding for STP to avoid signal reflection issues. All right, so let's move on and talk about signal degradation. And the first aspect we're going to talk about is called crosstalk. And this occurs when signal leakage from one cable interferes with another. And within that, we have what is called near end crosstalk. And this is interference at the cable sending end. And then we have what is called far end crosstalk. And this is interference at the receiving end. And when it comes to troubleshooting, you want to use higher capacity cables like Cat6 or higher to reduce crosstalk. You want to ensure proper cable separation and avoid running cables parallel to power lines. Next, we have what is called interference. So external sources like fluorescent lights, microwaves, or other devices, they can disrupt signals. When it comes to troubleshooting, you want to use shielded cables for STP or fiber to minimize interference. You want to keep network cables away from power lines and electrical equipment. Then we have what is called attenuation, and this is signal loss over distance due to resistance and cable quality. And when it comes to troubleshooting, you want to use signal repeaters for long distances. You want to upgrade the fiber optics for long-range connectivity. And you want to avoid exceeding cable distances like 100 meters for Ethernet, UTP, and STP. All right, so let's move on and talk about improper termination. So improper crimping, incorrect pinouts, and loose connections, all of this can cause connectivity failure. So when it comes to troubleshooting, you want to use a cable tester to verify correct wiring. You want to follow the TIA 568B and 568A standards for Ethernet cabling, and you want to ensure your RJ45 connectors are properly crimped. All right, next let's talk about transmitter receiver transpose. So this occurs when transmit and receive cables are swapped. And when it comes to troubleshooting, you want to check cable polarity with a network tester, and you want to use the correct straight through or crossover cable as required. All right, moving on, let's talk about some interface issues. And let's first talk about increasing interface counters. So errors in packet transmission, they indicate underlying issues. And within that, we have what is called cyclic redundancy checks or CRC errors. And this occurs due to corrupt packets caused by faulty cables, interference, or incorrect duplex settings. And to troubleshoot this, you want to replace or inspect cables for damage. And then you want to check your duplex settings because they should be matching on both ends. Then we have what are called runts, and these are packets that are smaller than the minimum Ethernet frame size of 64 bytes. And these things can cause collisions and duplex matches. And how to troubleshoot them, you want to enable auto negotiation or manually set correct speeds in duplex. And you also want to replace failing network cards or cables. Then we have what are called giants, and these are oversized packets that exceed the MTU limits. And to troubleshoot them, you want to adjust the MTU settings to match network requirements, and then you want to investigate the NIC settings for jumbo frame support. And then you have what are called drops, and these are packets that are discarded due to congestion. And to troubleshoot them, you want to monitor QoS policies and bandwidth usage, and you also want to reduce network congestion by optimizing traffic flow. All right, next we have what are called port status issues. And the first one is error displayed. So a switch port automatically shuts down due to security violations, such as the BPDU guard, port security, or STP loops. And to troubleshoot this, you want to identify the root cause showing interface commands. And you want to reactivate the port using shutdown or no shutdown commands. Then you have what is called administratively down. And this is when the port is manually disabled. And to troubleshoot this, you want to enable the port using no shutdown command, and then verify the port configurations and policies. And then you have what is called suspended. And this is when the port is in a suspended state due to mismatched channel configurations. And to fix this, you want to ensure the correct Ethernet channel settings, and then check your switch logs for error messages. All right, so let's move on and talk about hardware issues. And we're going to start with power over Ethernet issues. And within that, we have what is called the power budget that has been exceeded. So if the PoE switch exceeds its power budget, then new devices may not power on. And to fix this, you want to check the switch power capacity. And then you want to reduce the number of PoE devices or upgrade the switch. And then we have the incorrect standard. So using incompatible PoE standards, this can cause device failures. And to fix this, you want to verify PoE standards on both switch and powered devices, and then you want to use mid-span injectors for additional power needs. All right, next we have what are called transceiver issues, and within that you can have a mismatch, and this is using the wrong transceiver module for the fiber or copper interface. And to fix this, you want to ensure the correct SFP, SFP plus, and QSFP module is used. If you want to match the transceiver wavelength with the fiber type, then you have signal strength issues. So weak signals, they can lead to packet loss and slow speeds. And to fix this, you want to use an optical power meter to measure signal levels and replace or clean fiber connectors. All right, so in conclusion, troubleshooting cable and interface issues, this requires a methodical approach using the right tools and understanding physical layer fundamentals. So whether dealing with incorrect cables, signal degradation, port issues, or power over Ethernet problems, following structured diagnostics, this will help ensure reliable network performance. And by mastering these skills, IT professionals, they can effectively prevent and resolve network connectivity problems. All right, so let's do some check on learning. So our first question is, a technician is troubleshooting a fiber optic network issue where devices are unable to communicate. Upon inspection, they discover that a single mode fiber cable has been used instead of a multi-mode fiber cable. What is the likely result of this incorrect cable usage? Would this be excessive crosstalk causing signal distortion, a short transmission distance due to high attenuation, the link will not function due to incompatible optical transceivers, or interference from electromagnetic sources? And the correct answer is the link will not function due to incompatible optical transceivers. So single mode and multi-mode fiber cables require different transceivers due to differences in core size, wavelength, and transmission properties. Using a single mode fiber with a multi-mode transceiver or vice versa, this typically results in a non-functional link, and the signal may not properly propagate, which will prevent communication between devices. Next question. A network admin is diagnosing intermittent connectivity issues on a twisted pair Ethernet cable. Upon testing, they noticed significant attenuation over a long cable run. What is the best solution to mitigate this issue? Would it be replace the cable with a shorter one or install a repeater? Would it be use shielded twisted pair instead of unshielded twisted pair? Would it be increase the transmit power of the network devices? Or would it be disable auto negotiation on both ends of the link? And the correct answer is to replace the cable with a shorter one or install a repeater. So attenuation occurs when a signal weakens over long distances. The maximum recommended length for Ethernet cables is 100 meters or 328 feet. If a cable exceeds this limit, signal strength degrades, leading to intermittent or failed connections. So the best solution is to reduce cable length or install a repeater, such as a switch, to regenerate the signal. And our final question, a network technician is troubleshooting a switch port that is administratively down and is unable to pass traffic. What is the most likely cause of this issue? Is it a high number of cyclic redundancy check errors? Is it a manually disabled port configuration in the switch? Is it a cable mismatch between STP and UTP? Or is it excessive signal attenuation due to a long cable run? And the correct answer is a manually disabled port configuration in the switch. So if a port is labeled as administratively down, this means that an admin has manually disabled the port through the switch's configuration settings, such as using the shutdown command on Cisco devices. To restore functionality, the admin must enable the port using the appropriate command, such as typing in no shutdown.